Well, hello there. Tonight, we're going to talk about two-way tables, Venn diagrams, and probability. Because you see, every so often in these probability questions, we come across stories that lend themselves very well to a two-way table or a Venn diagram. Not every situation does, but one of the things that you're going to need to be able to do is read a story in prose and then draw a Venn diagram and then make a two-way table. Now, you also might have to go from a two-way table to a Venn diagram and back. But let's start with a story, and let's see if we can come up with a Venn diagram and a two-way table to match the story. And then we're going to look at one of my favorite Venn diagram problems. So here we go. Now, this problem came from a few years ago, back when people still used Pandora. So Pandora and Spotify at that point were the most used music apps. Here is a recent survey. Okay, so what we've got here is a story. This is in prose. Of course, I've got 3 probability questions down below. But what we want to do is try to come up with a two-way table and a Venn diagram to help us answer those probability questions. Now, this is a pretty straightforward example, but what you're going to see is that statisticians and probability people use the Venn diagram and they use the two-way table to help display information. So we need to be very comfortable with it. So let's see, we have 68% use Pandora, 38% use Spotify, and 24% use both. What should we try first? How about a Venn diagram? That came up useful last time. So let's see. Venn diagram, we have, in this case, 2 variables, right? Pandora and Spotify use, not use. So we'll put Pandora over here, Spotify over here. Now, if you would like to pause the video and see if you can fill in the Venn diagram, go right ahead. Here's your data, there's your Venn diagram, pause the video. Well, okay, we're back. Now, let's see if we can fill this in. When I do a Venn diagram, I always like to start with the both. So what's our percent for both here? Looks like 24%. So we're going to go right in here, 24. Now these are going to be percents. I'm just going to leave off the percent symbol. Okay, if 24% use both and 68% use Pandora, how much use Pandora only? That would
44%.
Nice. And then with Spotify, 14. Now, does that add up to 100? Let's see. 44 and 24 is 68, and 14 is 82. That must mean that there are 18% of the people in this survey who used neither. All right, and that's what we're talking about here with that nice Venn diagram. Okay, the Pandora circle, the Spotify circle. Now, look, the Pandora circle, 44 and 24, that's 68, check. The Spotify circle, 24 and 14, 38, check. 44 and 24, 14, 18, that has to add up to 100%. Remember, one of the rules we had for a valid probability model is that all the probabilities have to add up to 1 or 100%. Okay, so now we can answer the question. But let's do the two-way table before we get to the probability questions. So once again, we can pause, see if you can take this information to come up with a two-way table. Now, what would our variables be? How about Pandora? Yes or no? And Spotify? yes or no. So one of the things you're going to need to be able to do as an aspiring statistics student is make a two-way table from a story. So here's what I'll do. You've got the story, you've got the two-way table. Pause and see if you can fill those boxes in correctly. Okay, we're back. Let's see if we can do this. Let's see. Spotify, yes. Pandora, yes. Oh, that must be the box for the people that use both. 24. See, what else do we know? We know we had a total of 68 used Pandora. And a total of 38 used Spotify. Now, can we fill in the rest of our table? We sure can. I know my overall total has to be 100. That must mean this is 32, and this is 62. Okay? That must mean that this is 44, and this is 44 and 18, and this is 24 and 14. Now, did you see how I filled that in? I started with what I knew my total, and I just filled in the boxes so that this row, this column, and then finally my totals all made up to 100. You might want to review those last minute or so to see if you can see the order that I filled those in. Okay, now we're ready to answer our questions. The probability that we're Pandora, not Spotify. Looks like 44% here. Yes to Pandora, no to Spotify. So I'm going to say 44%. How about the probability for Spotify, not Pandora? From the Venn diagram, looks like 14. Let's see over here. Spotify, yes. Pandora, no. 14. And how about the probability of neither? In the Venn diagram, that's 18. And over here in my two-way table, no, that's also 18%. And this is it. Two-way table, Venn diagram, story. You need to be able to translate all three areas, okay? So it's not so much memorizing, just understanding what it is we need you to do with these problems. Now, before we go tonight, let's take a look at one of my favorite problems. In fact, this has appeared on every test I've given for the last 3 years. So since I'm showing it to you now, I'm going to have to come up with something new for this year's test. But let's see if you can do it. It's one of my favorites. It's a Venn diagram problem. I want to treat this as a Venn diagram. I mean, I suppose we could do a two-way table, but I always thought this lent itself very well to the Venn diagram. So let's see what we have here. We have our friend Pat. Pat applied to college A and to college B. The probability that Pat would be admitted to college A is 0.4. The probability that Pat would be admitted to college B was 0.5. And the probability that Pat would get into both is 0.2. So, our two questions are, what's the probability that Pat didn't get into either? And then, what's the probability that Pat got into at least one? Ooh, at least. There was something about that we've talked about in previous classes. Let's see if we can work that out tonight. Well, let's start with the Venn diagram. As I said, I think this lends itself very nicely. We have college A over here, college B over here. Now, if you would like to pause the video and see if you can fill this in, go right ahead. Well, and we're back again. Now, how do we start with the Venn diagram? Why don't we start with the overlap? It's the probability we're into both. Looks like 0.2. So the probability for A was 0.4, so that must mean this is also 0.2. And the probability for B was 0.5, so this must be 0.3. And this is a valid probability model. So 0.2, 0.2, 0.3, that's 0.7. So what must be in this space out here? That also must be 0.3. Well, what does that space represent? Well, these are the probabilities for admittance. So the space out here must be, that's right, denial. 0.3. Now, that means 30% chance of getting denied at both. What must be true of the other 70% of outcomes? So just think about that for a second. Let's repeat this now. We've done a Venn diagram. We've come up with a 30% probability that Pat will be denied at both colleges. So that means 30% of the outcomes are denied. What must be true of the other 70%? That's right. They have to include at least one admit, maybe both. So at least one admit is going to be 1 minus the probability of both denied. And that is 0.7. So Pat has about a 70% chance of getting into at least one of the colleges. This is an example of the complement, right? So we might call this the probability of a denial, and then this would be the complement of the denial, right? We write it with a little superscript C for that event. But the bottom line is the complements are when two items take up the entire sample space. Okay, like I said, I got to come up with a new problem this year. Whatever will I do?